Okay, since I did the last confidence interval with normality using Excel, I'm going to show you how to do it over in SALT for this one, for the T. So for SALT, you're going to, or let me adjust my screen a little, sorry, so we have the whole thing in here. So in general, the idea is that you want to find the critical value. We're going to switch over to the T distribution. Your degrees of freedom get set here in your little, I guess, clicker menu. You can see that as the degrees of freedom get smaller, the curve gets wider, right? So that's the point I was making a minute ago with approaching the normal. As the degrees of freedom get larger, this essentially becomes the normal distribution. All right, so say we have 10 degrees of freedom for this one, and I am looking for the critical value, right? If we do it in Excel, we have to use the left tail, and we need to set it so that we've got, the probability over here is 0.05, or, 1 minus half of your confidence interval, right? Whatever we need over here. Because when we do this way, right, 0.95 is in the middle, and we want to find what's out on the tails. Right. So in this case, using SALT, you can actually use this between, and we can find the exact critical values here, right? So say that we are doing a 90% confidence interval. So we need the probability of being between these 2 points to be 90%, right? That's the probability we're wanting. So 10 degrees of freedom, the probability is 90% between, and you can see that our critical values here are minus 1.81 and 1.81, right? So the critical value you're going to use in your margin of error computation for a 90% confidence interval with 10 degrees of freedom is 1.81, right? So that's how you can use SALT. If we were working with a 95% confidence interval, with a 99% confidence interval, that's how you're going to use SALT to find these values.